Let's talk about lesson 3.1.4. In the last lesson, we talked about how to know how to draw how many valence electrons and the arrangement of them around any element. And so what we're going to do now is actually use that knowledge in order to create structural formulas for elements besides the honk 1, 2, 3, 4 elements. So for example, what if I asked you to draw out the structure for Cl2? Well, if I draw Cl2's Lewis dot structure, I'm going to see that it's got 7 valence electrons and 1 lonely electron. If I draw a second one, it's also going to have 1 lonely electron. Same thing. So what if I actually draw the lonely electrons so that they're facing each other? Here's the lonely electron for this one. Now we can see they're sharing each other's lonely electron. That is the definition of a covalent bond, sharing electrons. Other things that might be similar, anything that has 1 lonely electron. For example, hydrogen. You could draw 1 hydrogen right next to the other. We just made an H2 molecule. Or how about another element in group 7A besides chlorine, like fluorine? Fluorine also has 7 valence electrons. And so you can see they would also like to share electrons. That would be F2. So for the activity it says, first draw some Lewis dot structures for the following molecules. First draw their symbols and then put your final drawings in the boxes below. Well, now that we've done some drawing, we can think a little bit about how we want to point those lonely electrons when we're familiar with it. So for example, we know bromine is similar to fluorine and chlorine because it's in group 7A. So I'm going to point those lonely electrons at each other. Those are the ones that are being shared. More often, you won't see scientists draw it like that. You'll see them draw the 2 that are shared as a line, and that represents those 2 electrons being shared. But for now, it asked us to draw the Lewis dot structures, so we'll keep doing that. H2S. I know sulfur has 2 lonely electrons, so what if I put 1 on each side, and then I draw my hydrogens on either side with their 1 electron. These are sharing, these are sharing. pH3. P has 5 valence electrons, which means 3 are lonely. So my hydrogens are going to want to share their lonely electron with phosphorus's lonely electron. Silicon has 4 valence electrons since it's in group 4A, and so each hydrogen would want to share one of those 4. It says, look at your drawings. How many electrons surround the bromine on the left? So if I count all of them, 1, 2, 3, 4, 5, 6, 7, 8. How many electrons surround the bromine atom on the right, including the ones that it's sharing? 1, 2, 3, 4, 5, 6, 7, 8. How many electrons surround the sulfur? 1, 2, 3, 4, 5, 6, 7, 8. The phosphorus, 1, 2, 3, 4, 5, 6, 7, 8. And the silicon. They all have 8. Well, what about hydrogen? Hydrogen's just a little guy, and it's happy just having 2. It says, how many chlorine atoms would bond covalently to a single carbon atom? So carbon has 4 valence electrons, and chlorine has 7 we've seen chlorine a few times now. So I can see that this would have room for 1, 2, 3, 4 chlorines. Why? Because carbon has 4 lonely electrons. Create a drawing representing the bonding of chlorine atoms with a single carbon atom. Start with the Lewis dot symbol for carbon. So it wants us to officially draw this out. So I'm going to sketch my 7 valence electrons for each chlorine, pointing the lonely electron at the carbon so they can share. How many fluorine atoms would bond covalently with a phosphorus atom? Well, phosphorus has 3 lonely electrons, so 3 fluorines could bond because fluorine has 1 lonely electron. So it'll want to share those. 3 because phosphorus has 3 lonely electrons. Create a drawing representing the bonding of fluorine atoms with a single phosphorus atom. Start with the Lewis dot structure of phosphorus. So again, it wants us to draw out what we were starting to visualize in the last question. It kind of gets tiring drawing so many dots, but they're important, and you'll see why when we start talking about shape. Now it says draw the structural formula of the molecule you created using the Lewis dot symbols. Structural formulas still include the lone pairs, but again, instead of drawing those 2 dots next to each other, you can draw it as a line between the 2. I like to show the dots making up the line, but I would say most people don't do that. What's the molecular formula of the molecule that you created? That would be PF3. The noble gases do not form bonds. Why do you think that's true? Well, the noble gases, like neon, have 8 valence electrons, so they don't have any lonely electrons. By the way, there's making sense that describes the elements wanting to have 8 electrons surrounding them as the octet rule. Of course, the exception to the rule is small atoms like hydrogen and helium. They're happy to just have 2. Hopefully that gives you enough to be able to answer the check-in and the homework questions.